We present a prototype of 3D scanner which reconstructs highly accurate geometry by merging multi-view and photometric stereo techniques. The method we employ for the 3D reconstruction has been introduced by Logothetis Mecca and Cipolla in a differential volumetric approach to multi-view photometric stereo, proceeding of the International Conference on Computer Vision 2019. The overall procedure consists of two main steps. The first aims at reconstructing the rough volumetric shape of the object using structure for motion. For this purpose, we customize the latest version of ColdMap so to have it working in a near-field setup. Secondly, we refine the point cloud using photometric stereo data from a number of artificial lights. As we aim at reconstructing the tail geometry of the object, our setup is limited in space as the device for the acquisition is fairly close to the inspected object, around 20 to 50 centimeters. The hardware consists of stereo camera setting based on two FLIR FLIA tree having 8mm lens each, 15 Osram Golden Dragon bright LEDs, 360 servo motor, two Arduino Micro, where the Arduinos have been used for communicating with the LEDs and the servo. At the prototyping stage, we used computer graphics tools to retrieve physically based multi-view and photometric stereo data in order to understand LEDs displacement, camera positioning, object distancing, etc. Most of this work has been carried out using Blender, which provided reliable rendered images simulating LED light propagation with point light source with specific amount of power, color, size, and so on. As during data capturing multi-view and photometric stereo images are acquired, the acquisition procedure consists on alternating the two following steps while the servo spins. Lighting the object uniformly using 3 LEDs in order to avoid specific light direction shading bias from multi-view. Flashing all the LEDs one by one sequentially, synchronized with the cameras for photometric stereo. As the lenses we used are fully manual, that is with a static aperture and focus, we decrease the aperture as much as possible in order to have the object on focus as much as possible. In order to have well-exposed images for both multi-view and photometric stereo data, we change the brightness of the LEDs via software using a power regulator on the PCB. Once the object spins on the turning table, multi-view images are processed during the acquisition so that the volumetric point cloud can be reconstructed and visualized on the go at acquisition time. During the acquisition, the camera poses are registered so that the photometric stereo data are projected onto the volume for accurate refinement of the shape. Since the angular rotation of the servo is not accurately assigned, we approximate the full rotation of the object with a progressive structure for motion reconstruction. Once the acquisition is completed, the rough volumetric reconstruction is filled with the Poisson shape interpolation, which provides the initial guess for the following shape refinement using photometric stereo data. The photometric stereo refinement is performed on GPU, where the OC tree is iteratively subdivided until the maximum accuracy is reached or the GPU memory is filled up.